At the end of yesterday, we saw this example was a little bit harder. Even though we had seen the original pattern of flipping the main and changing the signs of the opposite, we saw there was this additional piece of all of a sudden this negative 23. But hold on, so why didn't this guy have it? What would have been his, if you guys worked on homework or wrote down yesterday from our notes, what would have been his determinant? It's the snazzy name for it. How did we get the negative 23 for that other example? How would you plug in to a formula that you're supposed to be learning? AD minus B. 2 times 3 minus, good, B times D. What would that end up equaling? Which is? Nice. Make sure phones are gone, especially if you don't have your notes out and open and aren't following along yet. AD minus BC. P.S. The office can look into our room any time of day, especially when it's gloomy. They can see very, very well. And there's been a new push on cell phones not being allowed unless the teacher is using it. So just saying, Mr. Halliday's already walked by my windows 2 times this morning. Not for a specific reason, but just giving you a heads up. 6 minus 5 is equal to 1, yeah? So what would the formula have been? Technically, A inverse equals 1 over 1. So was the formula wrong? No. But what was the determinant? 1, so it didn't make a difference. But over here, what was the determinant? Negative 23, did it make a difference? Remember you guys went into your calculators and used the little -1 button? It can only be used for inverse with matrices. And all of a sudden you got all these weird fractions. Okay, this makes a big difference, which is why we saw yesterday. The formula for solving by hand, the inverse of a 2 by 2, if you are a highlighting, starring kind of person, and you did not highlight or star it yesterday, get it down now. There are 2 important things on this page that you need to have. First of all, the determinant of a 2 by 2, which it's a nice thing. We're going to actually go over this again in section 8.3, the determinant. I should say 8.4. But there's also the formula of solving an inverse by hand of a 2 by 2. Do you remember yesterday what I said I would let you do for inverses of 3 by 3s, 4 by 4s, 5 by 5s? Okay. But what do we need to be able to do or to solve? Yeah. Well, the inverse of a 2 by 2. Okay. And then we also looked at yesterday, we were quite a bit ahead of period 5. They got behind, when was it? Oh, the earthquake drill day, and they're just trying to catch up. We were able to look at this formula is going to work always unless we can't divide by what? Okay, so the only time it won't work is when the determinant is 0, but then we were also able to say, hey, wait. There's a special name for that. If the determinant is 0, it's not just that the formula doesn't work, it's that there's no possible inverse anyway. So we would just say impossible as in no inverse exists. And then we saw these special vocab words of invertible versus singular. Now, guys, that's the long story short. This is probably the easiest way to find an inverse is using the formula. Technically, that's the last thing I was supposed to teach you, though. Oops. Not the last thing. I mean, the undo thing is kind of important for an inverse. And these vocab are pretty important. But that's technically the last way I was supposed to show you. So I showed you the easiest way first. We did one example to end off class yesterday, but there's one other example we didn't get to. I want you guys right now to go ahead and use what we've seen, use what we've reviewed, take like 60 seconds, because the formula's in your notes, and try to solve for the inverse of letter B. And then we're just going to look at 2 other quick alternatives for other ways that you can solve, the other ways the book might have you solve for the inverse. And then we'll move on to section 8.4. We're going to go ahead and grade 8.3 tomorrow, but some of you with the formula were able to do most, if not all, of the homework last night. So good job. But for the rest of you, we will look at 2 other ways that you could use, just aren't quite as quick or efficient. Okay, 60 seconds. All right. Did you guys switch the main, change the signs of the opposite, and multiply by 1 over who? Why 0? That's 6. That's 6. And what are you supposed to do? So then what are you supposed to answer? No solution is good. Not possible. You could say no solution. You could say no possible inverse. However, what is another name for no possible inverse existing? What would be an adjective? Singular. Good. So you could just say none and then singular. But those of you that said no solution, you're right. You're not wrong. If you said something like the inverse does not exist, you're totally right as well. But there is no possible inverse because B is singular. Chris, go ahead, bud.
So right there where you put 1 over 6 minus 6,
yes.
Do you want us to be putting that even if it was 0? Even if the determinant was 0?
Well, you need to show me some sort of like, hey, I was solving for the inverse and it didn't work. Does that make sense?
Yeah.
And that way you're also practicing the formula, which is a good thing. Now, kiddos, I did say there were a couple alternative ways. So, okay, here's a couple alternative ways. Once again, you have the formula. You could check with the formula any of the examples that we do from here on out just to make sure that you have the formula down. Okay? But there are a couple other ways. One way is to set up a little baby equation and say, all right, what does an inverse do? An inverse takes a matrix, multiplies it by another matrix that needs to be of the same size, and gets undone. Let me give you guys a second. This method is saying, you know what? I'm going to take the definition of an inverse and say a matrix A times an unknown needs to be the identity. Is there a matrix? I want to find it. We can call it X. X marks the spot, who we want to solve for. Is there a matrix when I multiply by A such that, thank you, such that my original matrix will get totally undone to the identity? How do we do that? Well, what you could do is you could say, let's practice multiplying. Because even though this looks kind of out there and like, what do I do? Can I divide by a matrix? The answer is no, 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 no. We could multiply. And if we did multiply, we would get our, wait, how do I multiply? What's this finger do again? Over. Goes over, and this one goes down. And what I point to, I multiply. And when I shift, I add. Good. So this first one would be 1a plus 4c. 1a plus 4c. My first row, second column would be 1b plus 4d. My second row, first column, negative a minus 3c. Negative b minus 3d. Now I know, I multiply fast, but this is kind of review. All that's new is now we have these a's and b's and c's and d's that come up. But if you guys notice, don't I know what each of these little baby guys is supposed to equal? So couldn't I make little baby systems where I say, okay, 1a plus 4c needs to be 1. They need to match up. And negative a minus 3c needs to equal 0. They need to match up. Hey, it's a baby system. What else needs to be true? 1b plus 4d needs to be 0. And negative b minus 3d needs to equal 1. Another baby system. What do you guys think would be the easiest way to solve each of these? I was thinking elimination. Not that substitution wouldn't work. It totally would. It totally would. But what happens if you just add down to those little a's? Oh, that's nice. What happens if you add down to these little baby b's? Nice. So pretty quickly you could get 4c minus 3c is 1c. 1 plus 0 is 1. 4d minus 3d is 1d equals 0 plus 1 is 1. And if we know c and d, what can we do to go back and get the other two?
Plug and chug.
Yeah, go back and substitute. Go plug and chug it. So pretty quickly if I go back and plug in, maybe to there, a plus 4 is equal to 1, so a is equal to negative 3 if I subtract 1 minus 4. If I plug in, b plus 4d is 0. b equals negative 4. Don't you end up with, Has anybody done the formula yet to see? Here's my A inverse. According to this work, this is the guy such that if you multiply, I'll get the identity. Let's check with our formula real fast. Okay? Let's check with our formula real fast. Our formula would say, all right, you have a beginning matrix. Our formula would say, what should we do to the main? To the main we switch, flip, good. So -3, 1. And to the opposite we change the signs. What do I multiply by? 1 over AD, which is going to be minus -4. Good. Oh, that's going to be +4. What's -3 plus 4? 1. So my final answer would be -3, -4, 1, 1. Does it work? Yeah. Now, quick heads up. This formula, I'm coming right back to you, Jacob. This formula only works for what size? But guess what this process could work with? A 3x3, a 4x4, a 5x. But think, if it was a 3x3, how many letters do we have? A, B, C, D, E, F, G, H, I. It'd be a mess. But would this be possible? And the answer is yes. It would just be like this huge system of equations all over the board. Why am I not making a big deal about this one, even though it's good for 2x2s and above? Because I said you could use your calculator on 3x3s and above. Jacob.
Is that one hot, or one of those ones, why are they both positive?
These two flipped locations. That was a +1 and it stayed positive when I flipped locations. This one needed to change sign. So remember, the main flips, according to our formula, A and D become D and A. And then B become negative or opposite B and negative or opposite C. Does that make sense? Cool. All right. That's one alternative way. How could I check? We could multiply. We already know that. Okay. So this is the page that says, I think this is the only other alternate method. We already did that one. We just solved that. And that one's using the calculator. Okay, here we go. Last 2 pages. I said there were 2 alternate methods, one of which we just saw with A, B, C, D, and here's the second of which. Once again, why am I showing you alternate methods if there's the easy formula? Because the formula only works for a 2x2. The rest of them can be applied to bigger ones. And I know in your homework there's at least one where I ask you to solve it this way. And I'll explain to you in a second why. I know it looks more complicated, but it does have you practicing a very important skill for Chapter 8. And you can probably see it right here. Section 8.2, number 62, had you practicing RREF. In Section 8.3, this type of solving inverse will also have you practice RREF. So as you guys are writing down the steps, I'm going to apply the steps just to write down the first step in how to solve. Using this alternate method that once again you could double check with a 2x2 formula. once you guys finish writing the left. Go ahead and see what I've done on the right. I've taken a matrix. My job is to get an inverse. I've put it in what we would call a doubly augmented matrix. Augmented, we saw yesterday, just means put a matrix with dot, dot, dots and constants on the other side. But this time, doubly augmented, we're actually augmenting it or putting it together with the dotted line, a whole identity matrix. And what do you guys see right here in step number 2? So it's time to row reduce. Row reduce, here's the idea. Row reducing says, I'll take whatever's here and I'll undo it to an identity. Well, if we're undoing this side, whatever those operations are might show me the matrix that would undo it entirely. As I'm doing little step-by-steps of undoing individual elements, as I change those, if I can also change an identity, in essence, I will result with the inverse at the end. Because row reducing, in a sense, is doing little baby inverse operations to individual elements. So when, for instance, on the first step, I look at this 4 and I say, no, 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 I need this 4 to become, work by columns, get 1s and 0s. I need this 4 to become what? A 1. If I do 1/4 R1, 1/4 4 would be 1, 1/4 -1 would be -1/4. 1/4 of 1 would be 1/4, 1/4 of 0 would be 0. When I'm undoing that, maybe I'm also getting a part of my matrix over here for the inverse. Now remember, we leave the second row alone until it's time to tackle getting the 0s. But so far, did I get the 1s? Or get the 1 in the first column? No. I am going to add. I'm not multiplying, I'm adding. I'm adding to that guy. What do I need to add to that guy? 3. So how do I get a 3? Multiply row 1 by that 3. Remember the process? Getting 1s, we divide or multiply by the reciprocal. Getting 0s, we add the opposite. So I take the opposite, add. Remember, row 1's fine. We can leave him. He has the 1 that I need him to have. But this is the guy I have to work with. Times 1 minus 3, 0. 3 times -1/4, -3/4 plus 1 plus 4/4. -3/4 plus 4/4. 1. 3/4 plus 0. 0 plus 1. I know, I'm doing mental math. But back in the day, didn't we say we could go off to the side and you could show work, right? Okay. First column. Done. Second column. Ooh, what do I need to do first? Get the 1. Good. And how do I get 1? Multiply it by the reciprocal. Or 4. Totally right. But row 1's fine. I'm not allowed to touch him until I get the 1. 4 times 0. 4 times a 4th. 3/4. Oh, this is nice. 4 times 1. Go team. Do I have 1 in column 2? Yes. What's my job to finish off? Get that 0. How do I get a 0? Okay, true. I'm adding, right? And I need to add the opposite. So I need to multiply this guy by. Ooh, not the same. Opposite. 1/4. Just positive. Row 2 is good because he has the 1 that I need. 1/4 times, 1/4 times 0 plus 1. Good. Whew. 1/4 times 1 minus a 4th. 1/4 times 3, 3/4 plus 1/4, 4/4, which is 1. 1/4 times 4, 1 plus 0. According to this, it sure seems like my inverse would be 1, 1, 3, 4. We could check it with our formula if you want. It looks kind of right, right? But we could go back with our formula if we needed to and double check that he's right. I have 4, -1, -3, 1. So if I was to, awkward, if I was to find the inverse, wouldn't I? You guys should be masters at this formula by now. What do I do? Switch or flip the main. Change the signs of the, ooh. Wait, double check. What goes here? AD minus BC, that's 1. We're good. On the test, you're going to be using that. Totally fine. Okay? Totally fine for a 2x2. But in homework, if they're asking you for 3x3s or above, you wouldn't be able to use that. So then they're showing you other methods as well. Because the calculator, when you use, wait, how do you do an inverse on a calculator? The x to the -1 button, right? The programming couldn't use that for a 3x3 or above. So remember, we're kind of looking behind the scenes, not just how to use it, but where it maybe came from. You would have needed a process that would have worked for any size matrix. Okay, with that, we already talked about how to use the graphers. Let's talk about how to do this one last problem. Okay. How could you, using your graphing calculator, solve this with an inverse? It's not even a matrix yet, is it? You can kind of augment it. That's one way. You could, now that we've learned multiplication, you could factor out the column that was brought in, the down that was multiplied by the across. You could take out the variables. Even though you could augment and use RREF, the section basically ends with, whenever you have something, like a coefficient times variables equals numbers, kiddos, if this was algebra and you didn't know it was a matrix, how would you solve for x? If you didn't know they were matrices, you just saw this, solve for x. Divide by a, right? But can we divide by a matrix? So how do we undo? You would need an inverse. And what you do to one side, you have to do to the other. So the section ends with, how do you get rid of a matrix in an equation? You don't divide. You find the inverse. So you can say x is equal to a inverse times b. Could your calculator do this just as well as it could do RREF of an augmented matrix? Yeah. So RREF would solve this. You're right. This next to that, RREF. It would solve it. But you could also plug in a and do a inverse times b, and you'll get the exact same solution. Because the matrix that you solve for will end up being your x and your y. When you end up plugging that in, you'll get your x and your y. I hear a few of you plugging it in with your A matrix. You can use the little inversey button times B. I think that might be a problem in homework that we'll be checking tomorrow, so I'll check back with you guys and make sure that one makes sense, but you have the setup as to how to solve. With that, kiddos, we're going to go ahead and end class with starting 8.4. And the nice thing is, wait a minute. Haven't we already named this guy? Haven't we already seen this guy? He was the guy that was won over in our formula that we got really good at. Let me go check the air because it's getting mighty chilly in here. And as I check the air, can anyone help me fill in this formula that we just saw? 1 over is where we put it, but the actual determinant was AD minus BC. All right, let's get 8.4 started. Let's get 8.4 started. All right, guys, it'll be turning off any moment. There it goes. All right, I said Mari was gone and Noah's gone. Okay. Notation. The most basic one that you're actually going to find in your graphing calculator is DET of A. Where do we do stuff to matrices? Normally, the inverse was weird. It's like a button on the calculator that had a -1. The programmer said, let's make it an inverse, even though it's a reciprocal. Anyway, that one's weird, but where's the other matrix stuff that we've done? Where do you find it? Yeah, go to the matrix menu, second, whatever that button is. Is it X inverse? Okay, second X to the -1, get into the matrix. Where did we REF and REF? Yeah, second tab, the math, right? So in matrix math, you'll find, if you go look for it, you'll find DET, determinant. If you ever want to find with a calculator, on the calculator portion, the determinant, DET, okay? However, it's also going to possibly show up like an absolute value. Doesn't really mean absolute value, but we've seen this absolute value notation can be used lots of different ways. So absolute value of A means determinant. This is something that even honors this year had a struggle remembering, so you might want to put a little highlighted mark or star by this. Absolute value talks about determinant, and we could also put like the whole determinant in absolute value also, which you'll see from time to time. We're going to use it in section 8.5 a little bit. Actually, no, we're going to use it in this section 8.4 a little bit. So any of these are talking about C if it's a 2. A minus B by 2, A BC if it's a 2 by 2. But what did I just say? Only if it's a... Does this say determinants only of 2 by 2s? Okay. So there can be determinants of a 3 by 3, a 4 by 4, a 5 by 5, or beyond. But how do we do it? Last section, I was super honest about what I expect you to still be able to do by hand when you leave that section. Now, we did spend a lot of time, not a lot, but a little bit of time on the RREF, because isn't this an important process for all of Chapter 8? Okay, so we practiced it again, seeing how it applies to inverses, but the big idea, the big by hand I want you to pull away from section 8.3 is how to do an inverse of a 2 by 2. Struggle is 8.4, I'll be honest up front. You need to take determinants of things bigger than 2 by 2s. 2 by 2s are good, but you have to be able to take determinants of bigger square matrices also. So we'll see how to do that. But first of all, guys, rock it out. What is, for sake of notation, the determinant of A? Don't answer out loud. The determinant of B. The determinant of C. 3 different notations, but all of them are asking for the exact same thing. Master that formula just a little bit further. Not inverse, but the determinant specifically. AD minus BC. Go. Letter A. Who has an answer for me? Michael. Let's check it. Main 4 minus opposite. You guys agree? Remember, we're multiplying. Main 4 minus -3, 7. Got it. Who has an answer for letter B? Josh. 0. Main minus opposite. You guys agree? Ooh. What term could describe B? Nice. AKA, will he have an inverse? No. That was section 8.3, but anyway, he won't have an inverse. Okay. Letter C. Who has an answer? -3. Main minus, ooh, did you guys do that multiplication all right? 2 over 2 cancels? Good. Maybe our mental math is getting better. So, will A and C have inverses? Yes, just B won't. Okay. Good. We did some stuff in section 8.3. Now, let's start off with other determinants, not just 2 by 2s. I mean, we could practice 2 by 2s all day long, but hopefully you guys are kind of getting that formula and it's becoming second nature. We got to learn other ones. So let's start with a 1 by 1. Probably most of you wouldn't have even thought about that. There are 2 by 2s, 3 by 3s, 4 by 4s. What about a 1 by 1? There's just one element, one row, one column, one number. And guess what? It's going to be your favorite one ever. I think Nikki just said it. It's going to be itself. Go team. It's the easiest one ever. If you guys haven't gotten it, come on. The determinant of A, just itself, if it's a 1 by 1. So 2 by 2s, we have that nifty main minus opposite. 1 by 1s, you just steal it. So what's it time for? Okay, 3 by 3s are higher. 3 by 3s are higher. 3 by 3s, there are 2 different ways. One of them could be a shortcut for anyone who really likes mental math. But the other way is going to work for a 3 by 3, a 4 by 4, a 5 by 5, or a 10 by 10, or anything in between or above. So let's start off with the 3 by 3 alone trick. Sadly, it's 3 by 3 alone trick. It doesn't work for anything higher, and I need you guys to hear me on that. Do I have a trick slide? I don't have a trick slide. Okay. Oh, goodness. Nick, you cracked me up. Okay. I want you guys to write down this matrix. I'm going to go ahead and freeze the screen real fast so you can get it down. We're going to solve this 2 ways. One way with a 3 by 3 alone trick, and then with the way that's going to be able to be generalized for any matrix of any higher order, aka 3 by 3 or above. Ooh, that's a lot bigger than I meant for it to be. There we go. Okay, I want you guys to go ahead and write a quick little note to yourselves. 3 by 3 only. Okay? 3 by 3 only. Make a quick little note to yourselves. What I'm about to show you only works for a 3 by 3. It's a lot like the 2 by 2. So I'm going to say mental math. Because those of you that aren't good at mental math, this is probably a bad idea to do. And you'll see why in just a second. Mental math trick. But I told you to say only for a what? Okay. For the 3 by 3, here's the dealio. Could we do a main multiplication? Like we did for a 2 by 2. Could we do a main multiplication? Him times him times him? Yeah. All right, Joel, eyes up here. Yeah, we could do a main multiplication. Could we do an opposite multiplication? Yes. Here's the struggle. What would not get used? Okay, so that's not good, right? Because in the main minus opposite of a 2 by 2, everyone gets used in one of the multiplications. So here's the dealio. For a 3 by 3 trick, you rewrite the matrix as far as you need to let every term get included in either a main Zero got used in a main, 2 got used in a main, 1 got used in a main. Don't worry, you don't have to. And then everyone, 1 and 0, Sorry, 4 and 0 and 1. Everyone gets used in an opposite. Now you're like, whoa, 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 he never got touched. Oh, he got used. It's all right. Everyone got used in a main, and everyone got used in an opposite. So I should say everyone got used in a main or an opposite. Now you're like, whoa, what's going on? What do we do with the 2 by 2 formula when we go down? What operation? Multiplication. So the mains, there are going to be 3 of them. What's 0 times negative 1 times 1? 0. Plus, what's 2 times 2 times 4? 16. Plus, what's 1 times 3 times 0? All the mains, you keep the signs, and all the opposites, you subtract. If you want, you can think about them as being groups. All the mains added and all the opposites added, with a big old subtraction in between. What's 2 times 3 times 1? What's 0 times 2 times 0? What's 1 times negative 1 times 4? We end up with 16 minus, any of you guys that found the DET button in your calculator, why don't you check if we're right? 6 minus 4 is 2. Final determinant should be 14. See it? Yeah. Yeah, no, it's so easy. That's why this is dangerous. It's a dangerous trick. Some people who like mental math kind of like being able to quickly check a 3 by 3. The dilemma is it doesn't work on anything higher. 4 by 4s, 5 by 5s, 6 by 6s, no. Only a 3 by 3. Has anybody checked it yet to see if we're right? They're still checking. It's 14. Don't worry. The same matrix is going to be used again. So you guys can go ahead and write it down one more time. We did it with the 3 by 3 trick, but we're going to go ahead and see just the, well, we'll see it's solved with the longer process. We'll just have to use tomorrow to finish the longer process. There is another way to find it, and here's the alternative method. Ooh. Don't worry. It's all for a purpose. It's all for a purpose. I want you guys to write the matrix again. There is a general method that we can use to find the determinant of anything bigger. But my question is, can you guys follow the pattern? Can you follow the pattern? I didn't do it on the last matrix. What are you going to circle on the last matrix? Mm-hmm. What are you going to cross out? His column and row. And let me show you the other way to get 14. Take this number, 0, and you write next to it whatever's left. We'll talk about tomorrow why, but next you would write a minus with a 2 and everything that's left. We'll talk about tomorrow, but next you would write a plus 1 with everything that's left. And then you would find the little baby main minus opposites. Main minus opposites. Main minus opposites. To get the final answer. There were 2 other logistical things we needed to go over today. One of them I'm going to save till tomorrow. That was passing back your test, but they are graded and done and ready to come back to you. But the reason I am tabling that until tomorrow is because of the second logistic, which cannot be delayed. The second logistic is that tomorrow is March 14th. March is the 3rd month of the year, which means it is the one day that math teachers can be really nerdy and celebrate 3.14. Now listen carefully. We do need to figure out what I just did and apply it to 4x4s and 5x5s tomorrow, just a little bit. We do need to do that. To finish 8.4 tomorrow, homework will be due on Thursday for 8.4. Our test will be next week. probably Tuesday. Our calendar's getting bumped. However, the question that should be first and foremost in your mind is, how on earth are we going to celebrate Pi Day then if we still have to do work? We eat pie is a great idea. However, can I go out and buy pie for every single one of my classes?
Yes.
I don't want to, and nor will I, because you need to be involved in the celebration also, not just the eating part. So therefore, it's going to be worth 3.14 extra credit points in your test quiz category if you bring a circular, store-bought, or restaurant-bought. Doesn't have to be a, well, you could think outside the box as far as pies. Could you go to Marie Calendar and get a pie tonight? Yeah. Could you go and get bagel bites and bring them tomorrow? Hopefully not frozen because I don't have an oven. Yes. Could you bring maybe moon pies or those little cinnamon rolls that are really cute and in little Debbie snacks? Could you bring something else that's circular or even semi-circular, because isn't a calzone actually a better representation of a pie? Now, listen carefully. Listen carefully. You need to have with you when you come into class tomorrow whatever object that you are, store-bought or restaurant-bought, submitting for the extra credit. You will take it with you to your desk. I will mark off who has extra credit. You will bring it to a table that's up here in front. We will do some math, and then we will have time to party at the end. Sound good?
Would like brownie bites count too?
Oh, yeah. Circular. I count it.
Oreos are good, right?
Yep, circular. Let's go. Go, team. Although, if you bring one of those little... enough to share. Enough to share. Yeah, I'll technically have TAs put periods 1, 2, so you can actually put it under the table in the morning if you need to.
Are we going to receive our test tomorrow?
Yes.
How many people are in this class?
26-ish, I think.
Okay.
26-ish.
I need to know.
We'll say 30. That's a good thing. Where'd he come from?